Welcome to The Explainer. Okay, today we are pulling back the curtain on your everyday internet experience. We all spend, hours every single day browsing, scrolling, and clicking. But have you ever actually stopped to wonder how a website comes into existence? What's the invisible infrastructure making this whole digital world possible? Well, today we are going to completely demystify that for you. So here's a kind of fascinating question. Did you know that the massive websites you use every single day are actually running on Linux? Yeah, we're talking about heavy hitters, YouTube, Facebook, Google. Behind those super sleek interfaces, they rely on a surprisingly simple underlying technology, which is a Linux server. And honestly, the best part is that you can learn and build on this exact same foundation today. In fact, a lot of engineers really only click with how the network world operates after they've built a site from scratch themselves. Here is our roadmap for this explainer. We're going to cover websites and Linux basics, the 4 network steps, Apache versus Nginx, practically building your site, domains and HTTPS encryption, and we'll wrap up with modern web architecture. Let's dive right in. Section 1, Websites and Linux Basics. To kick things off, let's look at the absolute foundation. A lot of folks think websites are these mysterious, ultra-complex entities, but fundamentally, a website is incredibly simple. It's literally just a collection of files. You've got HTML for structure, CSS for styling, JavaScript for interactivity, maybe some images, and that's pretty much the whole shebang. Those files are just sitting on a specific computer somewhere out in the world, and we call that computer a web server. Now, nearly all of those computers run Linux. Linux is, without a doubt, the undisputed king of websites. It powers banks, massive e-commerce platforms, huge cloud infrastructures. So why Linux? Well, 4 core reasons. First, it's incredibly stable. A Linux server can run for years, literally years, without ever needing a reboot. Second, the performance is off the charts. It gives you incredible control over CPU, memory, and network resources, so it handles high traffic like a champ. Third, it's completely free. No wildly expensive OS licenses here. And fourth, it's open source, which means you have millions of engineers globally constantly patching bugs and locking down security. Section 2, the 4 network steps. Okay, so how do those files actually get from that Linux machine all the way to your screen? Let's break down exactly what happens behind the scenes when you type a web address into your browser. It's basically a micro journey in 4 steps. Step 1. Your computer asks a DNS server to convert that human-readable domain into a machine IP address. Step 2. Your browser establishes a secure TCP connection, which is typically on port 443 for HTTPS. Step 3. The web server software on that Linux machine receives your data packet. And finally, step 4, the server gathers up the requested HTML, CSS, JavaScript, and images and sends them right back to your browser. Boom, the website appears. Now, I want to pause real quick on that first step, DNS, because it's absolutely crucial. See, IP addresses are notoriously hard for us humans to remember. Imagine trying to memorize a random string of numbers like 93.184.216.34 just to check your email. No way. So DNS acts exactly like the internet phone book. It simply takes a domain you actually know, like google.com, and translates it into the specific IP address of the server holding that website. Section 3, Apache versus Nginx. All right, now that we know how the connection happens, we hit a pretty major engineering choice. We have to select the software that actually serves your files to the user. The 2 heavyweights in this corner are Apache and Nginx. Let's compare them real quick. Apache is kind of your old, reliable workhorse. It's got a deep history, massive compatibility, tons of modules. But its major drawback is that under high concurrency, like when a ton of users connect all at once, it tends to eat up a lot of system resources. On the flip side, we have Nginx. Nginx is the modern mainstream champion. It uses this asynchronous architecture that delivers just ultra-high performance. It is perfectly tailored for high-traffic environments, and that's exactly why you constantly see Nginx being used today for content delivery networks, reverse proxies, and Kubernetes setups. Section 4, practically build your own website. Now, theory is great, but getting your hands dirty is where the real aha moments happen. Let's shift gears from concepts to the actual practical empowerment of building an Ubuntu Linux server right now. Imagine you've got a fresh Ubuntu server sitting there. The commands are surprisingly straightforward. First, you just update your system and install Nginx by running sudo apt install nginx. Once that's installed, you check the system's CTL status just to make sure it's running. But wait, your server is currently locked down by a firewall. We need to open the doors. So using Ubuntu's uncomplicated firewall, UFW, you simply run sudo UFW allow 80/TCP for HTTP traffic and 443/TCP for HTTPS. And just like that, your server is ready to talk to the world. So next up, where do your actual website files go? Well, by default, Nginx is going to look in the directory var/www/html. If you navigate over there, you can create or edit the index.html file. You can use a simple terminal text editor like Nano and just type an HTML header tag that says something like Hello Linux Web Server. The exact second you save that file and refresh your browser with your server's IP address, there it is, your website is born. Honestly, the immediate gratification of seeing your code go live on the web is just an incredible feeling. Section 5. Domains and HTTPS encryption. Of course, you don't want people typing in a raw, clunky IP address to find you, and you definitely want your site to be secure. So this brings us to giving your site a real public domain name and wrapping the whole thing in HTTPS encryption. You know, transporting data in plain, unencrypted HTTP is incredibly dangerous nowadays. Hackers can easily intercept those packets and just read passwords, session cookies, credit card numbers, all in plain text. So HTTPS is the absolute core of modern website security. It essentially takes standard HTTP and slaps on a robust layer of TLS encryption. With this active, even if a malicious actor intercepts your data packet, it just looks like complete gibberish to them. They literally cannot read the contents. In the past, setting up this encryption was expensive and, frankly, super tedious. But today, it's beautifully simple, all thanks to a free service called Let's Encrypt. You just install a handy little tool called certbot, run the command sudo certbot-nginx, and follow the quick prompts. Within minutes, your server automatically procures a certificate, updates your Nginx configuration, and completely upgrades your website to secure HTTPS. It is such a massive win for the modern secure web. Section 6. Modern Architecture and Engineering Core. As we roll into our final section here, I want to scale up this foundational knowledge for a second. Because what you just learned isn't just for tiny hobby sites, it scales up to the absolute biggest platforms. A real large-scale website isn't just running on one single server. The internet request comes in, hits a load balancer to distribute the traffic, passes to an Nginx web server acting as a reverse proxy, routes back to an application server doing all the heavy processing, and finally pulls data from a database. Sure, behind the scenes you might have Redis caches, Docker containers, Kubernetes clusters, web application firewalls, but the fundamental concepts, DNS, HTTP, TLS, firewalls, and file systems on Linux are exactly the same. When you understand the basic flow we cover today, you are actually learning the bedrock foundation for DevOps, cloud engineering, and site reliability. I want to leave you with this really powerful realization directly from our source material. The entire core of the internet is just massive amounts of Linux servers communicating. By standing up a simple server, you've officially stepped into the real network world. The entire infrastructure of the digital age is literally right at your fingertips, just waiting for you to build on it. So if the entire global infrastructure relies on this open, accessible foundation, what incredible things could you build if you took control of your own server today? Keep exploring, keep building, and we will catch you in the next explainer.